In this example, we have Midtown High selling tickets to Spidey, a High School Musical. Adult tickets cost $5 each, and children tickets cost $3 each. They sold 94 tickets, making the total of $354. Write a system of equations to find out how many adult tickets and how many children tickets were sold. Then solve the system. So for this, um, looking at the different totals, we have a number of or amount of money. So we know that one equation deals with the total of money, which means we need something else for the other equation. The other equation is probably going to deal with the number of tickets. And remember, systems have at least two equations, so those are going to be the keys to our two equations. One equation dealing with the total of tickets, and one dealing with the total cost. The variables in this case is going to be the number of tickets of each type. So we have adult tickets and children tickets. I'm going to call adult tickets X. And we'll call the children tickets Y. Now you can also change the letters. So something else you might choose to do is just use A and C instead. But a lot of standardized stuff you'll see X and Y. So with that being said, let's go ahead and get started. So we know the total number of tickets sold is 94. If X is representing adults and Y is representing children's, then number of adult tickets plus the number of children tickets should equal 94. As far as the other equation goes, usually anytime you see the word each or per, it's going to be multiplied by the variable. So in this case, we have $5 each for adult tickets. So 5 times X, since X is the number of adult tickets, plus $3 each for children's. So 3 times Y is equal to multiplying $5 times the number of adult tickets gives you the cost, and this equation is going to represent our total cost or total amount of money earned, $354. So that's the setup for the equation, or the system of equations. Now we just have to solve it. To solve it, we can either use substitution or elimination. So I'm just going to go ahead and do substitution for this one. And get one of the variables by itself here. I'll subtract y from both sides. X equals 94 minus y. That was step 1. Step 2, we're going to replace x. So 5 times r 94 minus y plus 3y equals 354. That is step 2 for substitution method. We're going to distribute. So let's see, 450, 470. That's 5y plus 3y equals 354. Combine like terms. We have negative 2y. 470 is coming down. Equals 354. Now it's just the two steps, so we'll subtract 470 let's see, and I actually have to do some quick math here. Don't have a calculator at the moment. So 470 minus 354. So 6, 1, 116, negative. So negative 2y equals negative 116. And then we'll divide both sides by negative 2. So y is equal to 58. So there are 58 children's tickets sold. All of this was step 3. To finish off and do step 4, go back up to here. Do x equals 94 minus 58. Let's see, 94 minus 58 is going to be 36. So x is equal to 36. So in summary, I forgot to put this in a box if I keep things consistent. But if we summarize this, there were 36 adult tickets. Sold, and 58 children tickets. Just remembering that X stood for adult tickets and Y children tickets. In this example, we're flying to Gotham with a tailwind. A plane averaged 187 kilometers per hour. On the return the trip, the plane only averaged 122 miles per hour. So while flying back into the same wind, write a system of equations to find the speed of the wind and the speed of the plane in the still, if it was going in still air. Ooh. So this time our two totals are the 187 and the 122. The different variables are going to be the speed of the wind, because that's one of the things you were looking for, and the speed of the plane in still air. So I'm just going to call x the speed of the wind, and y the speed of the plane. Okay, and to do this, I'm just going to have to think about a situation. If you were to imagine walking against the wind in a very strong wind, you have to use extra effort to actually go the same speed when you're walking against the wind. But if you're walking with the wind, then the wind will add a little bit of extra motion to yourself. So if you're going with the wind adds to you. If you're going against the wind takes away from your speed. So if we use that for the first total, or the first direction, we're going with the tailwind. So that means it's pushing us from behind. So that means the speed we're going, the wind speed will add to our speed and equal the 187 kilometers per hour. However, if we're going against the wind, we'll have our speed, and the wind speed will take away from our speed, giving us 122 kilometers per hour. For this one, I'm just going to use substitution, or not substitution, I'm going to use elimination for this system. It's not quite in standard form, but since the y's are lined up, x's are lined up, and our constants are lined up, we really don't have to worry about changing the order of things. We can go ahead and use elimination right now. So I'm just going to go ahead and add my two equations since I already have a positive x and negative x. So 1y plus 1y is 2y. X's will cancel. And then that's equal to 200, 300, 309 it looks like. Yep, 309. And then we'll divide both sides by 2 to get y by itself. Bring my calculator up here. So 309 divided by 2. I'm going to double check the other one as well. 187 plus 122. Yeah. Okay. So we have y is equal to 154.5. Okay, cool. So if y is 154.5, we just need to finish solving. So let's go ahead and take my first equation off to the side here. So y plus x equals 187. We replace y with 154.5. Now we just have to solve, so we'll subtract 154.5. And x will be, if I go and do this, so it should be 32.5. I didn't change the order, so the sign on the calculator was backwards. There we go. So 32.5. So to summarize, the speed of the wind is 32.5 kilometers per hour. Per second, per hour. X representing the speed of the wind. And Y represents the speed of the plane in still air. So speed of plane in still air is 154.5 kilometers per hour. This example, we need to cut a piece of string that is 85 inches long into two parts. One piece that is 4 times longer than the other. Write a system of equations to determine how long you should make each piece. So, basically we just have two pieces, and since really we don't have anything special about either piece, X and Y are just the two separate pieces. A lot of the times with system problems, you're given two totals, and those are on the other side of the equation by itself. This time, however, we are only given one total, and that's the original string, before we broke it into two pieces, is 85 inches long. So that means that X plus Y, the total of our two pieces, should still be 85 inches long, even after we break it or cut it in half, or cut it apart. For the other equation, we need a little bit more information. So into two parts, if I continue to read, one piece is 4 times longer than the other. So I'm just going to use X, doesn't really matter which one I choose. X is, so one piece is 4 times longer than the other. To express 4 times longer than the other, 4 times what my other variable is, y. So here is the setup for the system. Since we already have a variable by itself, I'm going to use substitution to solve this. So we already have an equation with a variable by itself. Let's go ahead and replace in the other equation. So we're going to get rid of x, and we'll replace it with 4y. That's step 2. Step 3, combine like terms. So 4y plus 1y is 5y. And we'll just solve. 5. So y is equal to, just gotta double check it. Let's see, that's 85 divided by 5, 17. So we have y is equal to 17. To find the other piece, we're going to go back up to the equation that we boxed, which is the x equals 4y. We'll replace y with 17. So x is going to equal 4 times 17. And just a reminder, this is all step 3. What we're doing over here is step 4. 4 times 17. I don't know why my keyboard's coming up right now. 68. So x is 68. To summarize, one piece is 17 inches, and the other is 68 inches. That's it. Okay, so in this example, we're going to solve the system of equations. We don't have a specific method that we're supposed to use, so I'm just going to solve the system with substitution because I like substitution better. So I'm going to start with that second equation. I need to get one of the variables by itself. Since x is negative, I'm going to prefer to get y by itself. It'll be a little less work. So I'm going to add x to both sides. Get y equals, well, 3 plus x is just 3 plus x. So first step for substitution is done. I'm going to cross out the original equation so I don't accidentally use it. Now we're going to go to our other equation. And we'll replace y with what we found y to be equal to. So negative 3x plus 3 times 3 plus x equals our 4. Go through and solve. So that was step 2 there. And then step 3 is to solve. We'll distribute negative 3x plus 9 plus 3x equals 4. Combine like terms. Negative 3 and positive 3. Uh-oh. We're canceling out. We have an issue here. No, nothing was done wrong. It just happens to be that the variables cancel out. So if the variables cancel out, then one of two things is the answer. So it depends on whether what we're left with is a true fact or not. 9 equal to 4, that's false. Since 9 does not equal 4, it's a false statement, which means there is not going to be a solution to the system. And just as a side note, if it was true, for example, 5 equals 5, that would be a true fact, then there are infinitely many solutions. Just as a side note. But for this particular system, there is no solution. There we go. Okay.